Okay guys, so this is some math help on graphing inequalities. So let's start with one inequality. So I am on Unit 6 review sheet number 1. So we have this inequality that says y is greater than or equal to negative x minus 1. So the first thing that we need to remember is that if we have greater than or equal to or less than or equal to, we will draw a solid line just as if we are graphing y equals negative x minus 1. So since this is greater than or equal to, and it does have the little equal to line, we're going to graph a solid line. Alright, so let's just graph this as normal. Okay, so you have this 4-quadrant graph, and of course we're going to start at negative 1. And then we're going to go down 1 over 1, down 1 over 1, and we're going to draw a solid line. Okay, so now since it's an inequality, we need to shade it. So what you can do, you can look at the symbol, and since the original symbol says greater than or equal to, that means that we're going to shade above the line because it's greater than. So if you look at this line, this part up here would be the part that's above. Okay, but let's say you're not sure you picked the right part. So what you can do is find a point in that region, and so I'm going to pick 0, 0, which is right here, and that's going to be the easiest one to check, and I'm going to see if that's true. So I'm going to plug it in. 0 is greater than or equal to negative 0 minus 1. 0 is greater than or equal to negative 1. So that is indeed true. So since it is true, what I would do is I would shade this entire region of the graph. Okay, so this whole side. It's really important that when you draw your line, you extend it across the entire graph so that you can shade this whole entire region. Now, I'm not really shading up top of my writing, but I would also shade over here. Okay, so I'm just going to go ahead and draw over my writing. Here we go. So all of this is answers. So that means I could pick any point over in this region and it would be true. So let's say, for example, I choose the point 5, 5. That would also make it true. 5 is greater than or equal to negative 5 minus 1. 5 is greater than or equal to negative 6. So any point I were to choose over on that part of the graph would be true. All right, so let's try number 2. Number 2 is y is less than negative x plus 4. So remember I said you need to look at the symbol. If it is less than or greater than, we draw a dashed line to show that the points on the line are not actually solutions. If we plug in the points on the line, it won't be true. So I'm going to graph it much like y equals negative x plus 4, except I'm going to draw a dashed line. So I'm going to go to plus 4, and then I'm going to go down 1 over 1, down 1 over 1, etc. And this time I'm going to draw, notice how I drew a dashed, or sometimes we say dotted line. So it doesn't really matter if it's dashed or if it's dotted. The point is that it's not a solid line, okay? So now, secondly, I always need to decide what part I am shading. So I look at the symbol, and I can see here that this symbol says less than. So less than is going to mean below. Okay, so I think this is the part I'm going to shade. I am, however, going to check my answer. So I can plug in 0, 0 to here to check if that's correct. So 0 is less than negative 0 plus 4. 0 is less than 4. That is correct, which now means yes, I was correct. I'm going to shade this whole part of the graph, and so that is my solution. Okay, so that was number 1 and 2. That is basic inequalities. Okay, so now let's get into a system of inequalities such as number 3. Okay, so number 3. Now we have 2 inequalities, so what I'm going to do is the same thing that I was just doing, except for I'm going to do it, instead of once, I'm going to do it twice. Okay, so I will do them in 2 different colors to help you to see the difference. It's going to be on one graph though, okay? Okay, so I'm going to start by graphing the blue line. So I go down to -2, and then I'm going to go down 3 over 1. And then since it has a greater than symbol, remember that means it is a dashed line. That does not really look very dashed, so I'm going to erase some parts on it. Okay, there you go, dashed line. Now I'm going to graph the red line, which is y is greater than or equal to -3x plus 2. So I'm going to go to 2. I'm going to go down 3 over 1, down 3 over 1. Okay, and this is greater than or equal to, so it's going to be a solid line. Okay, so now I'm going to look and see where I'm going to shade. So on the blue line, it says it's greater than or equal to that line. So that means it's on this side, right? So again, I can check 0, 0, see if that's true. 0 is greater than -3 times 0 minus 2. 0 is greater than -2. That's true. Okay, so now I'm going to check the red line, and this one says greater than or equal to. So therefore, I have to pick something that's over in this region. So 0, 0 won't really work. Although I could plug in 0, 0, and then if it's not true, that means I shade the other way. But so as not to be confusing, let's just pick something over here. So let's say 5, 5. 5 is greater than or equal to -3 times 5 plus 2. 5 is greater than or equal to -15 plus 2. 5 is greater than or equal to -13. That's true. So I am shading above here. Okay, so if we look at the blue, if I were to shade this whole region above the blue, it would be everything over here. And then if I were to look at the red, it'd be everything above here. And so my answer is the part where it overlaps. So I'm going to show you in black where it's going to overlap. So notice the answer is actually just this part above the red line, because that's the part where the shading overlaps. So notice I shade darker so that I can see that my answer to this system of equations is just the part above the second line. Because if you notice, the part above the blue line was just the blue line, and I need to find solutions that work for both of these. And everything in the black part will work for both of them. All right, I'm going to do one more with you. I'm going to do number 4. So again, I'll do this in 2 different colors. So the first inequality is y is greater than -3/2 x plus 1. And the other one is y is greater than 1/2 x minus 3. Okay, so I have my 4-quadrant graph. I go +1, and then I go down 1, 2, 3 over 2. And remember, I'm going to draw a dashed line. So let me make it look dashed, okay? So I am drawing a dashed line because it is just a greater than symbol. It cannot also be equal to. The blue line also says greater than, so it's also going to be a dashed line. So I go down to -1, -2, -3. So I go down to -3. So this was down 1, 2. Okay, so I go down to -3, start there, and then I go up 1 over 2, up 1 over 2. Okay, and this is going to be a dashed line again. Okay, now, the shading part. So on the red equation, it says y is greater than, which means over here. So you can pick a point that is in the shaded region, such as, say, it looks like 1, 1 is over there. So 1 is greater than -3/2 times 1 plus 1. 1 is greater than -3/2 plus 1, so 1 is greater than -1/2. That's true, so I shaded the correct part. All right, so let me try this part. Again, it says 1 is greater than, y is greater than. So greater than, again, is above the line. And I can see above this line, 0, 0 does work, so I'll plug in 0, 0. 0 is greater than 1/2 times 0 minus 3. 0 is greater than 0 minus 3. Okay, so that's correct. Now, I look where they overlap. So if I look over here, it's just blue. And I look over here and it's just red. But this region right here, notice it's blue and red. So all the points in this little region of the graph would satisfy both inequalities. And that's how you show it on your test or quiz, is you'll just like shade it extra dark. I'm using 3 different colors, and you can use colored pencils if you want. But, you know, you can just shade darker with your pencil to show that that is the answer. Okay, so just a quick, if it is greater than or equal to, or less than or equal to, it's going to be a solid line. If it's less than or greater than, it's going to be a dashed or dotted line. Also, when you draw a line, if it is greater than or equal to, that's always going to be shaded above, right? So that's above. If it's less than or equal to, you are always going to shade below the line, okay? And like I said, you can always plug a point in just to double check that you shaded the right region. Okay, so hopefully you can work on number 5 and 6 on your own. On number 5 and 6, make sure you first put them into slope-intercept form. Do not forget that if you divide by a negative, you have to change the sign. So let me just help you with number 5. So you've got 2x minus y is greater than or equal to negative 3. Of course, I have to subtract 2x from both sides. This is number 5 in the review sheet. So again, I have negative y is greater than or equal to negative 2x minus 3. And then notice I'm going to divide everything by negative 1. And that's that rule about dividing by a negative, that I actually have to change the symbol here. So remember, this is going to be a solid line. And since it's less than, it's going to be shaded below. And on the second equation, you have x minus 3y is greater than 6. So of course we would subtract x. I'd have negative x plus 6. I need to divide everything by negative 3. And again, since I'm dividing by negative 3, it becomes less than 1/3 x minus 2. So it's going to be a dashed line. And since it's less than, I'm going to be shading below. Okay, so graph both of the equations on a coordinate plane and then shade the part where they overlap. All right, I will answer any more questions you have in class. Thank you.